This is the second video for decimal numbers, and we are looking at an application problem. To calculate the distance traveled by a bicycle with each pedal stroke, multiply the gear ratio by the circumference of the tires. If the gear ratio is 2.96 and the circumference of the tires is 81.5, how far does the bike roll during one pedal stroke? And so it tells you exactly what to do. We're going to multiply these two numbers that were given. And notice it says to round to the nearest inch. So 2.96 times 81.5, and that gives us, oh, my numbers are disappearing. Okay. It's one more of those fun things that happens with my Surface sometimes. So 2.96 times 81.5. Well, I think it's more with the program that I'm using, actually. When we multiply these, we get 241.24. And it tells us to round this to the nearest inch, and so that's to a whole number. And it would be 241. All right, so we're finished with that one. And don't forget inches. Yes, we always must label. Here's another application problem. To determine the thickness of a sheet of paper, 5 batches of 12 sheets each are measured with a digital micrometer. The thickness of each of the 5 batches of 12 is, I'm not going to read all those numbers to you, and it's in millimeters. Find the average thickness of a single sheet of paper. Now this one's a little more complicated than it sounds originally. We have 5 batches of 12 sheets. So how many sheets do we have here, right? Each of these is 60, or each of these is 12, right? Every batch is 12, and that means that we have actually 60 sheets of paper in this. Okay, so we're going to first of all just total up all these numbers, right? So we're going to total these. 0.7919, 7912, and 7917. So we add those all together. Let me make sure I wrote those down correctly. And we get 3.9569. Now that is the total of all these batches, and then we're going to divide to see what the average of these would be. So we divide by 5. There's more than one way to get this answer too, by the way. And that gives us 0.79138. So notice that is very similar to these numbers, which was the what was measured for each of these batches of paper. Now, each batch of paper actually has 12 sheets, and this asks us to find the thickness of a single sheet of paper. This actually is 12 sheets, right? That is the average for 12 sheets of paper. So then we're going to divide that by 12. So we're dividing it again to get to the average thickness for one sheet. And then we're going to go ahead and round it the same as these were. So that was 1, 2, 3, 4 places. And we end up with this. Now, when I draw this wavy equal sign, that means that we rounded. It's an approximate answer, and that's all that means. That's used in the book anytime there's rounding that happens. Okay, so this is a fairly long problem, and let me read it. Rivet holes are being drilled in the wing panel of an aircraft. Although the diameter of the holes is specified at 0.250, right, that's 250 thousandths or 25 hundredths, they are acceptable if they are within the range of 245 thousandths to 255 thousandths of an inch. To determine when a drill bit needs to be changed, the drill operator must take 3 measurements every 20 minutes and average them. If 3 consecutive averages show an upward trend, or if any of the measurements falls outside the acceptable range, then the drill bit must be changed. The following table shows measurements for 8 consecutive time periods. Find each average and determine if and when the drill bit should have been changed. Now notice it said if 3 consecutive averages show an upward trend. I'm going to highlight that. Or if any of the measurements falls outside the acceptable range. Let's see. And the acceptable range was this, so we can look at that when we look at our chart. So the table is going to show the measurements for 8 consecutive time periods, and we're going to find the averages of each time period. All right, so this will take us a little bit of time. I may pause the video and do some of the writing off the video just for time's sake, but here's what we're basically doing. We are going to add these, oops, got to change my pen. We're going to add these all together, get a total, divide by 3. Okay, so this one is 0.748, and we're going to round to 4 decimal places so we can see the change. Otherwise, we may miss it and not realize that there was one. Oh, by the way, look through the chart and notice that none of these measurements are at less than 0.245 or greater than 0.255. So we can ignore that part of the rules and just look at our averages. Okay, so I'm going to turn the video off and write out this work. Remember to round to 4 decimal places each time for accuracy's sake. All right, so I have part of these written out. I'm going to finish them. Notice that I'm at a point right here where this one has increased from the last measurement. So it went from 0.2503 to 0.2513. And this one also has increased again. That average is 2517. We're adding these. Dividing by 3. 0.2520. All right, so starting with this one, we have actually increased 3 times. So we can actually stop right here. The next one also increases if you add that one up. It is 0.759. So of course we know that it's going to increase for the average. So we would need to change the drill bit after the 7th time period. All right, so change after the 7th time period. So it's kind of a long problem, but I thought it was a good one just for a little bit of practice with decimal numbers and to actually answer this question. You know, what exactly are they talking about here? And it is a good problem. And you think about this was an aircraft. We don't want to be making any mistakes on an aircraft. Remember, the question was about drilling holes in the wing panel of an aircraft. So we want the wings to be secure and you want the measurements to be right. And so that's how you figure it. Now, if we had not rounded to 4 decimal places, it would have been hard to see that increase. And so going 1 more decimal past what these numbers were in the first place helped us see our changes. Okay, this is the last problem for this one. A land developer purchased a piece of land containing 437.49 acres. He plans to divide it into a 45-acre recreational area and lots of 3/4 of an acre each. How many lots will he be able to form from this piece of land? Okay, so here's the thing. He's got this many acres, he's going to do a 45-acre recreational area, and there's just one of those. And then the rest of it will be lots, and they will each be 3/4 of an acre. Let me go ahead and put that each in there. All right, so to set this up, we're going to take 437.49 and subtract 45, because we're going to do one 45-acre area. Okay, that leaves us with 392.49 acres. All right, that's what we have left after that 45 acre plot. Then we're going to split this leftover part into 3/4 of an acre each. I think I'm going to do this in decimal form, 0.75, which makes sense. 3/4 of an acre is 0.75 acres. When we divide this, we get 523.32. And then we would have to say we can get 523 lots that are a 3/4 of an acre size. And then, of course, we also had the 45-acre plot that's going to be the recreational area. But it said how many lots will he be able to form, right? And so that's our answer. All right, that's the end of Chapter 3. Bye, everyone.